this session of the coffee hour series from the energy sphere in UNITEN, University National. So today we will talk about some topic we have touched before, because it's a very recurrent theme and very recurrent need for this kind of topics. So we are talking about academic publishing again. Specifically, we are focusing after some terminology, some common terms, some common concepts around the publishing. We are also talking about the metrics, about how the journals or how the publications are ranked and how there's a sense of quality, and what are the very common currently used metrics to rank the journals, and something about the impact factors, scores, different kind of scores assigned to journals nowadays. Just one moment to share my screen. So while waiting for the others, actually, I hope you can see the screen now. Okay, we have. So Zahir, can you see the screen, please? The slides. Zahir or anybody, can you hear my voice and can you see the slides?
Yes, sir. Can hear you, boys, and can see the screen too.
Okay, thank you very much. So, just as introduction, this talk is actually one session in a series of talks we had this year, 2022. So this is called the Coffee Hour series, and this is the sixth sharing session from this series. We have actually more than one series. We have also another series about technical talks. So this series is not very technical. It's generally, handling topics of interest, for example, for postgrad students, young researchers, and that kind of things. So this is introduced to you by the Energy Sphere. Energy Sphere is just an office space for those who are joining us for the first time. It's an office space in the University National, like a collection of offices and labs. It is meant to be like a hub for training and R&D. So it includes a lot of facilities, especially labs, computer labs, and Internet of Things labs, for example, with a lot of spaces and meeting rooms and meeting rooms for workshops and etc. So your host is Ahmed Mubarak. My name is Ahmed Mubarak. I am attached to the IoT Planet Lab. So I am a member of the IoT Lab in the Energy Sphere. And today, again, we will just have short notes on the academic publishing and its metrics. This is topic, very important topic. I hope that you get something out of it at the end. So our agenda for today is first to take a very quick tour on the big picture. It's very important. So instead of just jumping and diving right into the details, first we will have a bird view on the big picture of the publishing and even academic research landscape. And we will see where publishing fits in this big picture. And then we will talk about what is and what is not academic research a little bit, just a few notes. And we will very briefly discuss why and where to publish. And then the meat of our talk will be around this note here, which is we'll talk about several common terms of publishing and also several common metrics of publishing. Things like impact factor, site score, SNP, SJR, etc. So then at the end, hopefully we have some time for a discussion, comments, and question and answers. Please feel free to interrupt anytime you feel so. If you have some comment, some question or a correction, please feel free to interrupt me at any time. So first, let's look at the big picture. So it all starts with knowledge. Actually, it starts and ends with knowledge. We are here, all the research first is all about knowledge. So you start from the knowledge that have been produced before you as a researcher, and then you end contributing to the knowledge, same body of knowledge you have started from, you have learned from. So it's all about creating new knowledge and learning from that knowledge and then contributing back to that knowledge. So from this knowledge, you will have a career probably. So most of you, I expect, have chosen this path as a career. So you are a researcher, and the researcher coming from the knowledge, most probably, usually, typically through a formal training. So for example, your degree as a master or PhD, it is kind of formal training to produce researchers. And those researchers will produce new knowledge. This is what is called roughly research. So the research activities is about producing, generating new knowledge. So this new knowledge has to be documented and written. Possibly writing process is also going in parallel with doing the research. So you can have writing with doing research. At the end, you have to document and write the results and the findings of your research into some kind of manuscript. This is a draft before publication, before being a publication. And this manuscript has two very important elements. If you want to produce a good manuscript, there are two very important elements. We have talked about that in previous sessions, and we may talk again about that in future sessions. These are the content and the style. So the manuscript will have the content, is about the findings of your research, and the style is about the presentation language of your manuscript. And this manuscript is meant to be, you know, disseminated and shared in the form of a publication. A publication, there are many forms of publications, but it's not possible to go directly from being a manuscript into publication. They are usually a process. So there is a kind of process you have to go through, starting from submitting your manuscript to somewhere that can officially disseminate your manuscript. But first, before that, you have to go through research, first a publishing process. So publishing process includes many actually steps. Most probably, it will go through a review, peer review first, then some kind of technical editing and production. And later on, it will be, if passed through this filter, then it will go into a form of publication, which is going back to contribute back to the knowledge you started from. And this publication usually supervised and managed and owned by a publisher. So we have a publisher, which is doing publishing and producing publications. All the publications are coming from the manuscripts. So that's the big picture. So we see now where publication fits. You have the manuscript and you have the publication. So today, we mostly will talk about these two and some kind of metrics for ranking and assessing the quality of publications. So before that, very quick notes. Let's define the research just to make sure we are on the same page, we have the same terminology. So when I say research in this context, in the context of this talk, what really I'm referring to, I have selected just couple of definitions. I hope we agree on that, but if you don't agree, please feel free to share. So we can define research in many ways. The essence of research, as I said, is just contributing or adding to the body of knowledge. So if you have some novel contribution, addition to the body of knowledge, that is the research, academic research in its essential definition. But let's let's have a look at two possible definitions. One of these, actually, from time to time, I'll refer back to this big picture. So from time to time, we will refer to this big picture. But for now, let's just define research very quickly. Maybe it is a systematic and objective form of continuous attention applied to a field of knowledge for finding solutions to a problem or developing foundational theories. So let's dissect this a little bit. So first we have this systematic. This is a keyword. These are the keywords. Second, we have this objective. These are keywords. So the activity is this continuous attention, and you have this continuity. This is also a very important keyword. By the way, this continuity, you can link it to this re prefix of research. Re indicates that there is some kind of repetition, iteration, and this continuous attention. The attention is what you do through your research. If you're observing something, experimenting with something, thinking about something, trying to produce something, trying to build something, evaluating something. So you have continuously exerting an attention which is objective. This is in contrast to subjective. So if two persons are doing this, they should produce the same. Of course, this cannot be 100%. It cannot be 100% objective. And it cannot be also 100% systematic. Systematic means there is a process, there is a steps. It's not random, it's not chaos. So it is repeatable, reproducible. And if two or three or more researchers are doing this process, probably they will follow the same steps. So a systematic means you have to learn this. You have to know what are the steps. This is mainly summarized in the form of what is called the scientific method. And then you have the objective keyword, continuous attention. You have also this constraint, which is also very important. Usually when you are doing a research, you are doing a research within a field of knowledge. So you cannot contribute to every knowledge or every kind of field. And probably your contribution and your continuous attention will be focused on a very narrow area of a field of knowledge. And the purpose is either to find solution to problems or probably to develop the theories, the foundational theories in that field. So you are progressing that field of knowledge by contributing theories which others can use to apply and solve some problems. Or probably you have a specific problem and you want to solve that problem. So this is a very general, but it has a lot of keywords that can apply to many, many fields. So generally, we can agree on that. That's what I mean when we talk about publishing academic research. We mean by academic research these kind of definitions. Or we can say it's an art of investigating new and innovative aspects of some branch of knowledge. This is highlighting this word. Although we have said it is systematic and objective, but this cannot be 100% all the time, really. So there is an element of art in that. That's why you cannot really reproduce exactly the results and the process of doing the same thing over 2 times, even for the same person. So, and probably 2 persons or 2 researchers will address the same problem, and probably they follow the same process, but they will produce something different. And there will be something element of creativity and innovation that's here. No new, which is sometimes referred to as novel, this is um, this is summarizing whatever we say when we describe a contribution, an addition. There is an implicit description of this contribution. When we say you contribute to the body of knowledge, we mean you contribute something new to the body of knowledge. So that's out of the way. Let me just share with you something very important about research, especially in the realm of engineering. It's actually applicable to any field, but especially in the engineering. Actually, I have taken this from a very good course from the edX platform. So this is called Research Methods and Engineering Approach. That's a useful course. I advise if you have some time to have a look at that. So there are a couple of slides I want to share some ideas from the introduction of that course. These are very important, especially for engineering students, to link that to the general landscape of research. So first, for everybody actually, engineers or else, research is again contributing to the body of knowledge, is making knowledge that does not exist. This is new. And the knowledge itself, let's talk about what this knowledge looks like. So the knowledge could be something about how to do something, some kind of a methodology or a method, or about something. So you add, you contribute something. It means a knowledge about something or a knowledge on how to do something. So all of these can be new knowledge. About something is the foundational theories we talked about here. And how to do something is some methods that can solve problems we talked about here. And research is making knowledge about the world around us, not developing an ability. I like this notice because there is a lot of confusion, especially among students, about what is exactly a research. So sometimes when you learn some skill, that's why sometimes you try to compare yourself with people in industry, and you find that it's incomparable. So you cannot compare because when you learn something, a skill to do something, this is an ability in yourself. So you internalize that ability. You are now training yourself. You are making yourself an expert or a skillful uh, craftsman, for example, in doing something. This is not necessarily research, although many students do this in university. So they try to learn and being skillful in doing something. So they try to do ability to themselves, and they think this is research. But you have to remember that research is about making knowledge about the world around us. It's not about, you know, planting or implanting skills inside ourselves. Although byproduct, necessarily you will have some research skills and you will build a lot of skills along the way, but that's not the purpose. So knowledge about the world can be written down. This is one indication of whether you are doing this or this. That knowledge can be written down. But if I ask you about your skill or your ability to do something, for example, your ability to program or your ability to build a machine or your ability to fix some kind of equipment, probably you cannot write down your expertise. So it's very difficult to explain what you have learned over the years. So, if you have a research, if you have new findings, it can be written down. So the ability, knowledge, it's inside a person. But the research that contributes to the body of knowledge, it can be written down. This is just one aspect from which we can distinguish between what is research and what is not research. So again, we will go back to this big picture. I will, uh, I will get rid of these basic definitions. There is one more slide about the basic definition. This is about knowledge categories. Let's talk about knowledge categories. So we know now what is knowledge in the context of academic research. And just to add more insight, what this knowledge can look like in the context of academic research, these are three possibilities. Again, from the same course. Again, I refer everybody to this course. But a question is, what are the kinds of things that we can write down? This is the knowledge we produce. What's the form of that knowledge that we can produce and write down in publications? These are three possibilities, very, very general. These are very broad, but you can apply them to many contexts. One of them is observations. Okay, so you make observations from the world around you. It depends on your field. These observations could mean many things. Or you can do some kind of recipes. Recipes means methods. Linked again to this. It's something to do something or about something. And also I link it to this definition. It's finding a solution or developing foundational theories. So you can produce or introduce methods and techniques and recipes to do things, solve some problems, and perform some tasks. These are also kind of knowledge. If it doesn't exist before, this is new knowledge. Or you can do observations nobody observed before, or nobody observed that from specific angles. Or you can model the real world. This is very general as well, but many of the research studies are trying to model physical phenomena, for example, the physical world. So you are modeling a process, you are modeling some structure, you are modeling the nature, you are modeling the behavior. So these are all forms of knowledge you can produce. So from that, let's just highlight a little bit about something um, very quickly. I will not focus on this, but what is not research? Especially, I will assume that this note is addressing specifically new students, especially master and PhD students, new ones. Please pay attention to these elements and these items. And please don't confuse this with doing research. Again, doing research is not having an ability in yourself. Doing research is about contributing observations and knowledge, creating knowledge about the world around us. So examples of the items that are usually not necessarily research, but very commonly thought by new students as research is playing with technology. So you have something, a package or kind of a technology, it could be software or hardware, and you're playing around with that. You understand that, and you're mastering how to perform different tasks with that technology. Or an assignment work. It's not an assignment work. Or producing a software, just programming. So if you're good as a programmer, good for you, because you can implement a lot of ideas. You can prove, you can evaluate a lot of ideas, a lot of knowledge you contribute. But just merely programming and doing some project, that doesn't make you a researcher. Or recycling others' work. Okay, there is a recycling in a previous version of this talk. In a previous version, I was writing here reproducing. Then I noticed this is misleading, because reproducing others' work could be research, could be an important type of research. If the purpose of reproducing others' work is evaluating others' work, building on others' work, and correcting problems or improving things. So this is, of course, research. So that I changed the word into recycling, which is very common among new students. It's not just recycling others' work, because if you are recycling the work of others, the ideas that have been produced before, you are not introducing new knowledge, and you are not creating new uh, things to the body of knowledge. It's not also about information gathering, like information retrieving, doing search on Google and other resources. It's also not only about information rearrangement. So if you are good at rearranging information, putting them in documents, that's okay. That's essential skill for doing research, but it's not research per se. And it's not about studying from books. This is an essential step to be a researcher, but you don't stop there, because everything in the books is already an established research contributions that have been already established, proven, then documented in a textbook or commercial book. And then it's not only about studying few papers only. That's again an essential step, but it's not per se doing research. And running a software, even successfully. This is very common among engineering students, especially with simulation. Again, remember, please, that whatever you publish, it should be documentation of new new observations and new knowledge. So something like you are writing down some new knowledge. But if you're just managing to run some software, it is a step to evaluate your findings or knowledge, to build some kind of prototype, doing experiments. Yes, but just managing to run the software and your contribution is to run some simulations successfully, that doesn't make that research. Okay, um, let's move to another element of our agenda today. So let's talk again very briefly about why, what, and where to publish. I will go very quickly through this because this is very common. You can find this everywhere, really, in every talk workshops. This is addressed extensively, but just because I cannot ignore it completely, I will just provide some hints. Then we move to the most important element of this common publishing terms. So for why, I will just read through this very quickly. So please, if you don't agree or you have some kind of question, please feel free to interrupt me. Otherwise, I will just read through them very quickly. I think they are self-explanatory, but if there is some ambiguity, please feel free to interrupt. So we publish because we want to give meaning to research. This means that, if you are doing a research and you are not disseminating the knowledge, the findings of this research, the new knowledge you have contributed, you have created, there is a little point about doing the research in the first place, but with some caveats. So there is a catch here. So you have to publish your research if you want to give a meaning to the research, and you have, because you cannot contribute to the knowledge. The community, research community, won't know about your research and won't know about the research, and your field of knowledge won't progress because they don't know about your new contributions. So you want to contribute to the knowledge in your field. You want to share your findings with the community, so the community will make use of your new created knowledge. But just notice, be aware that sometimes research can have meaning without publishing. And this happens a lot of times, actually. Two common examples is in military, for example, and in commercial products, where the findings of a research are considered secret trade, or secret of trade. So it's a kind of confidential. So many products, commercial products, they are built on extensive R&D, research and development, but not necessarily published. Also in the military, the same is happening. So sometimes research can have meaning without publishing, but most of the time in our context, without publishing, it can't have meaning. Also, you publish because you want feedback. How can you correct yourself, or that you are right or wrong if you don't publish and share your knowledge, created knowledge, with others? And it is also, there is one good reason to publish, even if it is um, not meant to do this, to contribute to the field, is that it forces you to clarify your ideas. Actually, the process of writing the manuscript for the purpose of publishing, it really forces you to clarify ideas and to fit your ideas in the context of the current state of the art in your field of research. Without writing down your findings, it's probably your ideas will be a little bit ambiguous and vague until you put them down on paper. And also sometimes there are more materialistic benefits or reasons. For example, as a requirement, you see this kind. Sometimes you publish because you have to, because it's requirement for graduation or requirement for promotion. This is the KPIs. Or you want to publish because you want to establish your name in your community. So this is about credibility and recognition. Because if you want to share your results with others and you want others to accept your contribution, you have to be credible and recognized. So you have to have a name, kind of authority, how people trust and have confidence in your contributions if you don't have this kind of credibility or recognition. So this is establishing you as a member of the research community in some field. And sometimes you want to publish. This is happening many times on the level of institutions and countries, to have influence. So if some country or some institute or some company or some university, they want to have influence on the progress in a field, they have to produce a lot of publication and a lot of publishing that steers the progress in some way. And of course, there are some a little bit more some benefits around the self. So like prestige, having respect, or also sometimes you can gain financial benefits from publishing. What to publish? Again, I think it's obvious by now, but those observations, the models, and also the recipes and methods you can produce, those forms of knowledge can also take a little more granular forms. For example, this could be new inventions and discoveries. Discoveries could be new observation, a new method for doing something. Theoretical foundation, these are mainly observations and models that models the real world. Experimentation and implementation, about techniques to do something or to verify something or evaluate something, probably previous results. New concepts, new metrics, new approaches, new protocols. Sometimes these new concepts is a new model or theory. Sometimes these are methods, things or ways of doing things. Or you want to enhance existing practices, again, some kind of methods. Or you are doing a large scale data analysis. So this is also about processing the observations for the purpose of maybe producing new models or proving new results or previous results, and some kind of analysis, model development. Modeling is a very important actually part of research. So all these are just saying what we have said before. In other words, it's a little bit more granular forms of knowledge you can create. And if you can create that knowledge, probably you want to document, publish that knowledge, whatever form it is. So then all of this also, in addition to referring you back to this slide we talked about, also you can think of all of these as data-driven forms versus methods forms. So some of them, they have a lot of data, like observations, and they want to use this data to analyze and produce models, new modeling, for example, of the processes, of behaviors, of natural phenomena. Or methods, you are just producing new techniques, protocols, algorithms, new recipes to doing some things. Where to publish? Very quickly, if you want to know what are the venues that you can publish in your new knowledge, you have few sources to look into. So one is the list of references in your resources. So if you are referring to some papers or references, probably the bibliography of that reference, the list of references in your paper, this will give you a good start in some suggestions about, because those references are published by some venues like journals. So this is a good a good start to look for possible venues to document and publish your research. And you can have also a look at bibliographic databases. We'll talk about this later on in the other half of the talk. So we are just about the half, so we'll move now into the publishing metrics. So there are some kind of citation indexes and bibliographic databases. some databases like you can search into. Some of these databases are produced by the publishers themselves. Like, for example, if there is a publisher like Elsevier have database of data science, or another one like Wiley have their own database. Springer, they have Springer Link. IEEE, they have IEEE Explore, etc. So a lot of publishers, they have their own databases. And some companies, they are producing indexing services like WOS, Web of Science, Clarivate, and the Scopus from Elsevier. So all of these are producing a source to search for papers, or for ways, for journals, for venues to publish your knowledge. And also you can have recommendations from your supervisor, your colleagues, and any experts in the world. Actually, nowadays you are lucky because you can find and access experts either in person or online, anywhere in the world. If you want some help, you want to automate this process, there are some websites, tools actually, software tools provided by different publishers, like, for example, Elsevier, Springer, and this is from IEEE. So you can use this. You can use this actually websites, tools. You can open this later on. These are clickable links. When I will share these slides with you, so you can click on these, and you will find that these are websites, okay, software tools, where you can provide some kind of keywords, even the title, sometimes even the abstract of your paper, of your manuscript, the unpublished paper, which is, we call that manuscript. So you provide the keywords of your manuscript, the title of your manuscript, sometimes even the abstract, and this tool will suggest some journals, some venues for you to publish your manuscript. Okay, now let's move into, in the second half, let's move into the most important, really, um, uh, like item in our agenda, which is, let's talk about publishing itself. So moving away from the research, what, why, and where, into the common publishing terms and some metrics. So I will refer you back to the big picture again. So this is the big picture. We said you start from the knowledge and you end to the knowledge. You start through formal training, becoming a researcher, producing manuscripts. I will ignore this part now, and also this part. This deserves other talks, and indeed we have some other talks about this, about the writing process, for example, and this is also addressed by other workshops, and about the submission process, the review process, and we'll talk about these two elements. So after your manuscript goes through the filter of publishing process into being a publication, the publication is produced by a publisher. This is the owner of this kind of publication, and through this is the process of publishing. So we will talk about these two. First about the publisher a little bit, then about the publications, type of publications. Yeah, we'll talk about first type of publications, something about publisher, then we will talk about how to assess these publications and what are the metrics used nowadays to rank these publications. First of all, let's look about the type of publication venues, where type of the places where you can have this publication. So the publication itself could be a book. Of this could be textbooks, or could be monograph by one author, and it could be journal. I'm sure most of you are familiar with this kind of venue. Could be an edited book. So this is the author of this book is actually soliciting publication, soliciting contributions from other researchers and compiling that. This is peer review book. And then a book chapter. So this is a single part of this, and could be conference proceedings. So the papers presented in conferences, they are usually compiled in the proceedings of that conference. So these are peer-reviewed, usually. This is it should be your main focus. But there are other kind of venues. You can have also technical reports or white papers. These are other forms. Usually, sorry, this is not referring to here. And also trade publications like magazine produced by companies, so around some products. But we will ignore this here. So for example, if you go to Scopus main website and search for sources, usually the name of the venues in Scopus is called sources, like the name of journals. You will find this source type. So you can filter the papers you want to search for based on the type of the publication. So like journals, book series, conference proceedings, trade publications, etc. So this is about the publication type. But if you look at specific, then we'll focus here on the journals. But let's talk about a little bit of these. I'll talk about conferences and journals mainly because they deserve special attention. So the conferences, as many of you know, this is very useful. Conferences very useful for quick dissemination of your research. So you go to this venue, a conference, and you present your knowledge, your manuscript, actually the accepted manuscript, which is the paper, in this conference because you want quick dissemination. So you don't want to wait too much for your knowledge to be published. This is usually the conferences have shorter review process, that kind of this filtering process you go through. Usually this is quicker in the conferences. And in some areas, you have to notice that although conferences are undervalued nowadays, and really they have less the perception that conferences are less prestigious and have less value than journals, for example. But you have to notice that in some areas, prominently in computer science, especially in computer science, the impact of conference papers are exceeding those of papers. So there are, for example, some series of conferences like ACM series. Top researchers in the world, they compete first to publish in these conferences first. And after being accepted by these conferences and presented, probably the same paper, then it will be archived, it will be published in a journal. This is not in every field, but in some fields, especially computer science. And also conferences provide an opportunity to verbally communicate and follow up discussion with and have follow-up discussion. And it helps explore new thoughts and extensions if you are attending the sessions, attending the presentation sessions, and collecting new ideas. And if you are paying attention while attending, of course. And also, a very important benefit of attending conferences is to build your network. So it facilitates interactions and networking with peer researchers. It's a very important aspect that is missed nowadays, and you are missing on this if you are not attending conferences. Journals, of course, we agree that journals are the most prestigious. This is the archival form for publications. So journals are archival. Usually, their nature is that they archive, they document and keep the knowledge that is produced in the field. So anybody later on that want to go here and start from the knowledge, one important archive to look into is the journal. So the length of the papers in journal usually longer than conferences, and the research effort usually is expected to be more mature and rigorous. It's not quick dissemination. It's already established results. And usually also you spend more time in the review process and production process. So the turnaround time between the submission and the publication being published is not really fixed, and it varies a lot, but most of the time it is long, from several months. It could be, okay, nowadays could be several weeks, by the way, with the trend of open access journals. So it could be several weeks into several months and could exceed 1 year, sometimes 2 years, if it's possible, or more, by the way. So the peer review is more rigorous. The peer review is more rigorous in journals. And just as a fun fact, the first academic journal was this journal. I will not try to pronounce it because I'm not sure this is Journal des Scavans or something. It was produced in Europe in January 1665. Then followed immediately by Philosophical Transactions of the Royal Society in March 1665. So this is the dates of the first journals in their current forms. Now, if I restrict my attention to journals, you can find many kind of articles. One piece, of manuscripts are published in journal is called an article. And there are many forms of articles, like research articles where you produce new results, or short reports or letters. This also new results, but it's usually very short. Sometimes you don't wait until your project finished and your results are confirmed because you want very fast dissemination. You just write a very short letter, could be two pages or 3 or 4 maximum. Or review articles. This is called secondary source of knowledge, where you just summarize and criticize the works of others. Could be case studies, where you take an example and you do analysis based on some kind of examples. For example, you want to analyze some kind of behavior, and you look into a specific community or a specific company, for example. Methodologies or methods. So sometimes nowadays, this is newer trends. These are newer trends here at the end. So there are journals that accept papers that just explain a method you followed to produce the results, because the methods could be new and could deserve emphasizing, or could be data paper. So data paper means you collected the data set, which is very important for others, and you just document your data set in a paper. Could be editorial, which is just contribution by the people working in the journal, like the editing team, and usually this is not peer reviewed. So all those are just types of journals. If you look at journal articles, if we focus on research articles later on, let me first give you a quick note on the publishers. Okay, this is like, you can consider it fun facts, but please have this perspective. I want you to have this kind of knowledge, because many of the new students, they miss this. So, okay, probably in this last century, around 1960s, 1970s, suddenly we have the emerge commercial publishers that began to acquire and purchase the best journals that used to be published by non-profit academic societies. So we have usually universities and academic societies. They are non-profit, and they produce journals. These journals have been acquired by those publishers. And although there are thousands of them, thousands of publishers, because this is a good business, by the way, only you can notice that this is actually the source of this information from Wikipedia. You can notice that 5 for-profit companies, 5 commercial companies, namely Elsevier, Springer Nature, Wiley Blackwell, and Taylor and Francis and Said, these are responsible for nearly 50% of all the published articles. So it's a huge percentage. And you have to notice that this is very profitable business. So the margin of profit in this business is around 40%, which is exceeding most of the other sectors, most of the other industries. So why is this? Is probably because of this. Because unlike most other industries, publishers, they get a lot of free material, free everything. So they don't spend as much on their product as the other industries. So they get 2 most important entries in academic publishing almost for free. What is the product? The main product you are producing, the articles. You get them for free from the authors, and even you can even receive money from them. And also a very important process, filtering process. Like you can imagine this as manufacturing the item, manufacturing the raw material in other industries. The peer review process is also done voluntarily, most of the time for free. So that's why it is a very profitable like activity, very profitable business. Please keep this in mind, because this will help you in the future to understand a lot of the trends and to contribute in some of the debates. So now let's talk about the ranking of the journals. So we have journals produced by publishers, and those include the contributions of the knowledge by the authors and researchers. People soon came to realize that especially when there were a lot of contributions done every year, nowadays every day. So many manuscripts, many articles are produced daily, and the number of publications is huge. It's really overwhelming. So people needed a way of ranking, means indications of, okay, I will use this word, although this word is really misleading, but I will say the quality. Although this is not very good word to describe what we are doing when we rank journals, but this is the closest thing that I can approximate or approach this topic. So to have a sense of quality of different journals, and by extension the articles published by those journals, probably I need a way. So first, this is what we need, journal ranking, and we need that in the academic circles to evaluate and have a sense of the quality of and the impact. This is another word used with quality of an academic journal. So should I refer to these articles published in this journal? should I contribute my manuscripts and publish in this journal? And in the past, traditionally, academic institutes used to do that. So the university themselves, for example, their departments or faculties, they will evaluate and rank journals through their experts. So there will be a panel of experts in each institute, and they will evaluate and rank the journals. The problem with this method, it is politicization, the bias, because remember, the people who are ranking journals from different institutes belong to one institute. So this is the view of one institute only. People, they have shared interest and they have same policy, and they are trying to rank everything else. And also there is also a wide disparity. There is difference in evaluation methods between different institutes. So one journal could be ranked differently in many institutes. This is not very good. And then the quality of journals also can be evaluated by another traditional way, which is surveys. So not only the experts in one university or institute, you have a survey and you distribute that survey to many experts in many universities and try to collect their feedback, and then try to build some kind of ranking of the journals. This is a little bit better than the previous one, but still suffers from similar problems also. So then attention has shifted recently, actually from the mid of the last century, to a set of what is called bibliometric scales, some scores, some kind of scores or scales, bibliometric related to references, related to academic work. So this is coming from bibliography, which is the list of works in any academic piece, manuscript. So at the level of journal means we are just trying to have sense of the impact of a journal from the list of uh, references. Especially, we will not look at the reference in a whole. We'll only look at the reference itself, means the citation itself, only the act of citation, of mentioning some journal in other publications in their reference, in their bibliography. So this can be used as a measure of quality, and by this we eliminate the need for self-evaluation by experts, panels of experts. So the researchers have proposed several journal level metrics. So this kind of metrics, bibliographic metrics, many of them exist, but almost all of them, or most of them, they are based on the concept of citations. Citations means this is a journal and they have many articles. They have published many articles. And then we look at the other journals, the other articles here. They have these references at the end, the bibliography. And these references are one of those articles in this journal. So this article is citing an article from this journal, means it is mentioning an article from this journal in their list of references. So these citations are analyzed, and from that you try to make a sense of the impact of this journal. A lot of other articles in many other journals, they are referring to this, citing these articles in this journal or not. So, and there are in fact many of these metrics. Later on, I encourage you to click on this link. There is a file here that lists a lot of these metrics, but I will provide examples for a few of them now. So for the bibliometrics, very quickly, I will read through this slide because this is just giving you some background about bibliometrics. Bibliometrics use statistical methods in analyzing those citations and those kind of information to analyze the books, articles, and other publications. So these methods are now widely used in the field of library and information science. Actually, now it is used in every field, but in the past it used to be only in library and information science. And there is a subfield of bibliometrics that is concerned specifically with the analysis of scientific publications, what we talk about, and this is called scientometrics. The scores that I will explain now in the coming slides, these are kind of specific special case of the bibliometrics, which is scientometrics, because it is only scientific publications, ranking scientific publication journals. So the citation analysis is commonly used bibliometric method, the citation analysis. So somebody is analyzing the citations the number, the cross references between different journals. And um, it relies on representing citations between documents, between articles, in the form of a grid or graph. Usually they have some kind of visualization, kind of analysis. But most important is that this citation analysis is documented, and the results will be kept in citation indexes. So the company or the institute or the people who are doing the analysis of these citations, they will keep the results of this analysis in a database, in a kind of index. You just think about the index at the end of a book. So this are telling you this is happening where, this is happening where, this is happening where. So it's documenting the cross citations between different journals. This journal, how many citations it receives from here, how many citations from here, on average, how many citations a single document have in this journal, etc. So this kind of analysis are documented in indexes. So this kind of indexing of citations, this emerged as a new business. Initially, it was designed as a means of just retrieval of information. Means I want to have a look at, this one referred to this one, so maybe this one is related to this one. I want to refer to both of them. But then it's used to frequently. Now it's used. Okay, this is, but it is also provided data that was used in assessing the impact. Now it is used to assess the impact. Also, although I can follow the citations among the cross citations among journal and articles inside journals to retrieve information, related information, but of course I can also have an idea about, okay, this journal have been cited too many times. Most of the other documents, they cite articles in this journal, so maybe this journal have a lot of impact. The articles used to publish here, it's important because so many people refer to this frequently. So that's the idea about citation analysis. So a citation index is a database, is a kind of product, is a bibliographic index. So citations are indexed between publications among journals, making it easier to identify what is the later documents referring to the previous documents. And the first person who did this kind of citation analysis is this scientist, Eugene Garfield. This is the person who initiated this. He founded what is called Institute for Scientific Information. So this is very familiar to you, ISI. That's the origin of this ISI term. It's just an institute created by Eugene Garfield. So this is the Institute of Scientific Information. This happened in 1950s, 1956. He wanted to provide academic publishing services, particularly in the analysis and indexing of citations. So he studied citations among different journals. He documented that. He indexed the journals. He put the journals in his index with information about the citations they receive and the citations among them. So he built an institute. And in 1960, this institute introduced its first citation index for papers, something like a report citation index for papers published in academic journals. And the name of that database, this citation index, was Science Citation Index, SCI. This is the name of the first kind of citation index, like a database. Think of it as a database, index for citations. The first one was SCI. Later on, you will know that people, when there's so many scientific, they produce the next people who manage this institute, they produce the expanded scientific citation index. So this is another database. This is what is used nowadays. So later, the social science citation index. This is the first index for science. Then for the journals from social sciences, also they created SSCI, Social Sciences Citation Index, another database. And then for humanities and arts, we have Arts and Humanities Citation Index, AHCI. So we have now SCI, ESCI, and SSCI, and AHCI. I am listing this because maybe you are confused with this. You will read about this. You will see this thrown somewhere when you are doing your studies, especially if you are new to doing master or PhD. So these are the meaning of these things is kind of databases, kind of citation indices, and they are combined in one product at the end. This is called a Web of Science. So these indexes later evolved into the Web of Science. So Web of Science is the website or the collection of all these databases. And this is actually owned by companies. After this ISI Institute, it was owned by Thomson Reuters and currently by a company called Clarivate. So other sources of such data include Google Scholar or Scopus from Elsevier. This is also providing kind of citation indexes, citation databases. So let's look at the two most important kind of these services. Okay, so citation services, citation indexing services. So there are many products, but um, this can be called databases. Can be called databases if you wish. But among the most prominent citation indexing databases, citation indexing, because they are doing indexing of citations and they're providing this as a service. But we can call them database because they store bibliographic research data. So this is the Web of Science, this database or this indexing service. This is from first ISI, uh, created by Eugene Garfield. Now it is owned by Clarivate Analytics. And before that, it was owned by Thomson Reuters. Another citation indexing service is Scopus. This is owned by Elsevier publisher. So both of them are available via subscription. You have to subscribe to get this information, although Scopus, most of the information are free. And they vary greatly in the cost. Of course, Scopus being much less expensive than WIS. And both are selective. They have some kind of filtering system. So they are selective. They don't include any journal in their database. They have to apply some kind of criteria or condition. But generally, WOS, Web of Science, is more selective. It's more difficult for a journal to be added or indexed in this database. And both are commercial services, by the way. And there are other free services, but we will not talk. Let's first roughly, in a few minutes, sorry, I will take a little bit more time if you are okay with that, because I want to survey a few specific metrics of this. Even if you understand what is the concept of indexing services, let's look at specific examples of these metrics used, kind of scores you provided by these services. So for Web of Science, again, I will skip on this because the most important thing about Web of Science, if you want to know about this, most important thing is that it is a kind of collection of databases, and it is a website, and it used to be called Web of Knowledge. If you hear about this, if you are if you are a little bit old, coming from some previous decade, maybe you heard about Web of Knowledge. This is the previous name, and it is providing subscription-based access to multiple databases. We talked about those databases, ASCI, SSCI, that provided comprehensive citation data for many different academic disciplines. It's not only one field, many fields. And it was originally produced by the ISI Institute and is currently maintained by Clarivate Analytics and previously by Thomson Reuters. And this person, which is Eugene Garfield, is considered as the father of citation indexing. So if this citation indexing is good, he's a father of a good thing. If this citation indexing is bad, then he is the cause of this thing. And he launched this Science Citation Index, which in turn led to the Web of Science. So the Web of Science is a collection, again, of databases. The core are here. So this core collection includes 20,000 or more peer-reviewed, high-quality scholarly journals published in over 250 science, social science, humanities disciplines, many disciplines. These are just metadata. It's not very important here, but you have to know that when you find a journal that is mentioned in this database, we call this indexed. Index in this database means their citation analysis is included in this database. When you find the journal, remember that the journals are selected for inclusion not easily in Web of Science. So in Web of Science core collection, which include science and social science and humanities, etc., there is a set of 28 criteria. 24 of them called quality criteria. Okay, this quality is mostly about editorial rigor and best practices. So it's not really about the content; it's about the formalities, about the editorial soundness and the best practices followed by the journal. So if a journal cross that filter, it is joining something called emerging sources. But then there is also 4 impact criteria. This impact criteria is about the content, mostly is about the citation. It's about the citation. If you cross this, then you will be joining to the core collection. You will be part of the core collection. You will have a number. You will get a number. This number is called impact factor, and you will be included in a report, annual report called JCR, Journal Citation Report. So journals that meet the quality criteria, they will be in emerging sources citation index. This is important because remember this emerging, not expanded. Sorry, they expanded previously. I mentioned they expanded as at the start. This is wrong. Expanded is here at the end. Sorry for this. When I refer to the core databases, expanded is at the end. SCIE. Actually, the E at the front, which is the emerging, is the first step. This is new. This is from 2015. Many students, they find that the journal is indexed in this database, and they say this is ISI. Actually, it is one step into ISI, but it's not the same as the core collection. It's not the same as the journals with impact factor. These journals, they have no impact factor. They have no impact factor. So from only 2021, they are starting them just last year. Clarivate starting to include journals indexed in this database in the JCR, in the annual report, only from last year. Before that, it was not even mentioned in the JCR, and they have no impact factor. But this is a first step. So this is the first step. After the quality criteria, 24 criteria, they are indexed in emerging sources citation index. Then if they prove themselves and they qualify for the 4 criteria about impact, they will be joined into one of these SCI or SCIE or SSCI, etc. So journals that meet the additional impact criteria enter the Science Citation Index Expanded, Social Sciences Citation Index, or Arts and Humanities Citation Index, depending on the subject area. And remember that index journals in SCIE and SSCI, from these 2 collections, from these 2 databases, they are given an impact factor. Impact factor is a number that we'll talk about now. And they are published annually in a report called JCR. Only from 2021, these journals already started to be mentioned in the JCR. In addition to SCIE, SSCI, now it is also ESCI mentioned in this report, but ESCI still have no impact factor. Only those 2 have impact factors. Okay, this is the same knowledge, so refer to this later on. So we start from here into the WOS, the Web of Science. If you have 24 criteria, you go into one of these 3. If you have 28, criteria. If you have only 24 criteria, you go into E, emerging, ESCI. Then if you are improving, you will be joining here. If you are already here, but you dropped in your quality, you will be moved again to here. And if you lost the 28 altogether, you will be losing your qualification. So this is the process of indexing into WOS. And WOS also includes a lot of kind of publications. So in SCIE, you have in the journals, these are the main 2, science and social science. So these are journals. So these are the main databases. We have also humanities and emerging sources, but also among the collection, the books, but it's not in the core. You can see from here. The books are outside this, proceedings, conferences, and the emerging sources. So these are the 3 are the most important parts. And this is how to evaluate a journal to be included, but I will skip this because it's not important for us. It's important if you are creating a journal. If you are building a journal and you want your journal to be included in the database, in WOS, one of the databases, then you should be aware of all these quality criteria and impact criteria. Now, let's talk quickly about the impact factor. Okay. Okay, so impact factor is one of the scores given to journals. So the impact factor, sometimes called IF or sometimes called journal impact factor, JIF, is again, it's a score, scientometric, sciento because it's from scientific journals. And it's a bibliometric, it's related to citation. It's an index of scholarly journals that represents the average, this is the meaning of it, is the average annual, every year, number of citations received by articles published in the past 2 years in a journal. So the impact factor of a journal is the number of citations received by all the articles in that journal. Okay, in for the citation means mentioning in other journals, they are mentioning articles in the last 2 years. So this citation is not forever, it's not all the citation, is only citation of last 2 years. So I am in 2022, I have published an article, okay, and that article citing an article in the last year or in 2021 or in 2020. So all the articles, they have cited how many of these citations for articles in the previous 2 years only. So if I am mentioning, for example, if I am an article, I am mentioning a journal article in 2019, for example, this will be not included in this calculation. Only the citations that are referring to journals in the previous 2 years, and over the total number of published articles in those 2 years. So if I am calculating, we'll see this in the next slide, but this is the idea. So this is like an average number of citations. How many citations? How many publications? So overall, oh, you have a journal. You include a lot of articles, maybe 100 articles. Okay, but okay. In for example, last 2 years, we are talking of, this is the window of impact factor. 2 years, last 2 years. So if I am calculating the impact factor of this years, I am looking to 2021 and 2020 for the impact factor of 2022. So I am looking at the all citations in those for journal articles in those uh, um, articles. I am looking for all the articles in 2022, all the citations in 2022 for articles in the last 2 years. And I am looking also at the total number of published articles in the last 2 years. And the result will be like the average number of citations for the articles in the last 2 years over the published articles in the last 2 years. So it's like an average citation for each article in my journal. So this is a journal level score. And this factor is frequently used as a representative of the relative importance of the journal in the field. Journals with higher impact factor, of course, they're supposed to be more important and having more impact. So the impact factor was designed by Eugene himself in an ISI, and now it is actually this kind of analysis is done by Clarivate, and the result of this analysis is produced in a journal citation report annually. So now the calculation of impact factor is for each journal. So they do this analysis and calculation for each journal, and then every year they update the impact factor for each journal which will have this number. So this is Eugene, by the way, and this is the original paper he wrote about the topic. And then this is the calculation of impact factor. This is for reference. So if you couldn't follow me, you can refer later on to this slide to understand the calculations. So the annual JCR impact factor is actually the ratio between citations and citable items, citable articles. So the published articles, because not every, by the way, the word citable, because WOS, they don't include any publication. So if it's not only anyone mentioning you, they will be included. Only research articles and reviews. Only research articles and reviews. These are the type of articles that are included in this kind of calculations. So again, the impact factor of a journal is calculated by dividing the number of current year citations. Means in 2022, I see the journals in 2022, how many times they cited journal papers in the last 2 years. So the citations in 2022, 2 articles in the last previous 2 years, over the total number of published articles in the last 2 years. So for example, if A is total cites in 1992, in 1992 you have maybe 150 citations, okay, maybe, and B is the cites to articles published in previous 2 years. So out of this 150, maybe, for example, 100 is for these 2 years. 100 citations is for 2 years. So I look for B. I want B. I want B, the number of citations for articles in these 2 years. This is subset of A. Then I look for C, number of articles published in these 2 years, and then I divide B over C. That's the impact factor of this current year of 1992. Again, this is another one from Wikipedia, so you can refer to Wikipedia for more expanding explanation about this. Okay, that's about impact factor from WOS. Now let's move into scores of Scopus, because I mentioned there is another second important indexing service, and this time from Elsevier, is Scopus. Scopus is, again, we can call it like citation index database or citation index service. So for this, we have several actually scores, not only one, but the most important one is what is called cite score. So again, as an introduction, Scopus is a database that includes citation and abstracts. So you can also, in Scopus, you can look for the abstracts of the articles. It is started only in 2004, by the way, not like ISI 1956. It's only in 2004 by Elsevier, is a publisher. And it is including more. It's more thorough, more extensive than WOS. So it includes, for example, 27,000 active serial titles, more than 7,000 publishers, of which this number, 25,800 plus, are refereed journals in the fields of different fields. And they cover the following types of sources. So they include not only journals, but books, journal, conference proceedings, and also trade journals. So it's a little bit more broader than WOS. And all journals included in the Scopus database are reviewed each year to produce, update the scores to ensure the quality standards. Sometimes they exclude journals from the database altogether if they lose some quality. Sometimes even you can find in Scopus database very bad actually journals. They discover this soon and they try to catch up and exclude journals from this. So the most important scores here is cite score, SJR, and SNP. Very quickly, actually, I have all this documented, but very quickly, maybe we can go through this. You can find this from the Scopus website, and you go to the sources. So you click on sources, and then for the sources, you can search for specific title if you want. But if you didn't, it will be all the sources will be listed, all the journals will be listed, and for each journal, you have what is called the cite score, and SNP score, and SJR score. This SJR is coming from a site called SkyMago. It's done not by Elsevier, not by Scopus, by a third party. And this is done by Leiden University in Netherlands, some university. So only this is done by Scopus, by Elsevier. And this is very similar to the impact factor, but different tweaks. And we'll see the difference now. So for the cite score, if you understand the impact factor is almost the same with some differences. First, it includes 4 years, not only 2 years. And second, it includes the current year, not only the previous years. So in impact factor, only the previous 2 years. But for the cite score, it is 4 years, including the current year. So if I am calculating the cite score of 2016, I will include the citations for papers in 2016, 2017, 2018, 2019, and divide by the number of publications in 2016, 2017, 2018, 2019. That's the difference, but the concept is the same. So the window is larger, but overall, this is A over B. The same concept. Okay, so, and there is another difference, important one. It includes all these, not only research articles and reviews, but it includes also reviews, conference papers, book chapters, and data papers. So in kind of impact factor, in the impact factor, only uh, articles, research articles, and reviews are included from Web of Science. Of course, when you include the citations from that database, so for WOS, only the journals that are indexed in WOS will be included. And for Scopus, for CiteScore, only all these kind of publications in Scopus will be included. But because Scopus include a lot more journals than Web of Science, usually you can find that they overlap. Mainly, Web of Science is a subset of Scopus because Scopus is more broad. So almost most of the journals in WOS will be just part of Scopus, but many of the Scopus will be outside the indexing of WOS. So this is just highlighting more information about CiteScore, but the concept is already what I told you. So again, CiteScore, the problem with CiteScore and impact factor, they have a problem, a little bit problem. That's why they included these two. Uh, uh, so CiteScore is not used to compare journals in different disciplines. That's a problem with not only CiteScore, but also with impact factor. Usually, the number of citations relative to the publication is not the same in different disciplines. Some disciplines, they are very active. They are publishing articles all the time. Citations are done, generously. This is the nature of the field. But some fields, like the number of studies by nature, is much, much limited. And also the citations also much limited. And sometimes one article will include less citations because there are less articles to refer to. So you cannot compare an impact factor of a journal in some field with an impact factor of a journal in another field, and you say this is better than this. This cannot be done. So even when you rank journals, now what is done in the journal citation report JCR, you have to select the category, the field, and within the field you can have a sense of the impact factor. So to solve this problem, to compare the journals indexed in Scopus from different disciplines, they have introduced. You can either use the percentile ranking of CiteScore, which is here. Is one way, or there is another score. Another score is to use the SNP, and SNP is another score, kind of number, which is called source normalized impact per paper. Okay, just roughly, I will ignore all this slide, but roughly, what's the idea of SNP? The idea of SNP is it will take the differences between the different disciplines. So the score of SNP will be the average number of citations per paper. Okay, the average number of citations per paper in a journal. This is same like before. But the denominator, it will be divided over the number of citations expected. So now we are not dividing by the number of publications. We are dividing by the number of citations expected in that field. So if, for example, in that field, this is sometimes called the potential citations in the field, citation field, or field citations. So for example, you get 50 citations in this year. And by the way, this is for the 3 years, last years. So the number of expected citation means this field should have this number of citations in the last 3 years. How they know that? This is their secret, but there is a way to know that. But anyway, the idea is, let me finish this one. The idea is you have received 50 citations in this year, but in your field, the average expected citations is 100. Means usually the other journals in your field, usually they have 100 citations in the. This is coming from 3 years, by the way. So this means you have a half. You have a SNP score of half. This is, you are okay. You are in the mid range. If you are very good, okay, you will have more than one. If you are not very good, less than expected, you will have less than one. So if the number of expected citations is the same as what you got your citation, this is number one. This means you are okay. You are as everybody else in your in your field. But if you are more than one, like you got 100 while the expected is 50, you have two. This is means you are good. You are better than average. You are much better than average, for example. And how they know that what's the average? Actually, there is an indication. So the number of citations expected in an area, in a field, is the average number of references in each document cited or by a journal. So you see a journal, okay, and you see the references referring to what? And you go to those documents, and you see the average number of references. So for example, this usually have 15, 20, maybe for example 25. Then all of them, the average, they have an average of 20 reference per document, which are cited by this journal, because citation by this journal means they are in the same field. So if on average the number of references are 20, means the expected citation is 20, so they compare to that. So that's the idea of SNP. This is just one. There is an institute called SkyMago, and it's done by another institute, and this is a measure of prestige. This is called a measure of prestige. It's not about reputation. Journal impact factor, the site score, and the SNP, they are all called reputation metrics. Reputation metrics means how many citations you get. But this SJR looks into who are those journals that are giving you citations. So this is about the prestige also. So this is a measure of journal impact as a combination of the number of citations that the journal received and the importance or the prestige of the journals that cited you. So that's the idea here of SJR. This is very similar to Google search. The PageRank algorithm from Google, when you search for something, they try to list the results of search, and they do some similar kind of algorithms. They see the results who are mentioned, and not only that are mentioned the most, but by most important other references. Okay, there are some comparisons between different here. I will skip that. You can find them in the slides. Some comparison about journal impact factor, site score, about different scores from LCP, from Scopus, site score, percentile, SNP, and SJR. So you can refer to this later on. The last one we may talk about, again, so sorry, so probably you can later on refer to the slides. I'm sorry, I have taken a lot more time than expected, but let me just finish with this last score. This is the last metric that can be used to assess the journal. Actually, originally, this H index, this is H actually referring to a person, which is called George Hirsch. So this is a person who suggested this metric in 2005, sorry. So this is originally introduced to rank not the journals, but the researchers, the people, the researchers. But then you can extend that to journals and countries and institutes, etc. So the H index is an author level. Originally, it's for indexing or for ranking the researchers, the authors, rather than the journals. So this is an author level metric that attempts to measure both the productivity, how many articles you produce, and the citation impact, the articles you introduce, the quantity, and also how many citations they receive. So not only how many you publish, but also a little bit of the impact of the things you publish. So how many also citations those articles receive from others. So the index is based on the set of scientists' most cited papers and the number of citations that they have received in other publications. So let's define that. This is a definition is mentioned here. It is defined as the maximum value of H. Okay, it's a little bit complicated, so please focus for the last time. This is the end of it. So it is a maximum value of H. So H is a value, and how you derive this H is the maximum number such that that author, or could be extended to journal also, has published this number of papers that have each been cited at least this number of times. So again, H, it's difficult to understand. So H, you look at the number of publications and the maximum number of publications that received this number of citations. So to make it clear, let me give you an example. So if I have a publications like I have 1, 2, 3, 4, 5, 6, 7, for example, 7 publications in the last 5 years, or in from the beginning, all of my publications are 7. Just imagine that. So what I want to do, the first publication, the first journal received, for example, 5 citations. The second one, uh, also 5. Maybe then this one 4. Okay, this one 3. This one 2. Maybe this one received 1, and this didn't receive anything. So this is an example of the number of citations I got for each of my publications. So now, what is H? What is my H index? The H index is, now I go down. This is already ordered by the most, from the most cited to the least cited. So I find this is 5, 5, 4, 3. I look for the maximum number. So is it that receives that number of citations? Means 1 is 5, 2 is 5. Is my H index 5? Is it 2? I have already 2 publications, each received more than 2, but maybe it is 3. I look for 3 because I have already 3 publications, each of one received 3 citations. So it's maybe 3 because each of them received 3 or more. Maybe it is 4. Is it 4? Okay, the problem is I cannot get an H index of 4. Why? Because I have 4, but not each of them got 4 citations. You see the difference now. I have 4 this my number 4. This get 3. This got 3 citations only. So I don't have 4 at least. I don't have a maximum. I don't have at least 4 items, 4 articles, each of which have 4 citations. 4 H is the same number. So that's why I will stop to here. So my H in this case is 3. H index is 3 because I definitely have 3 articles, each of which receive 3 or more citations. This one received 5, this one received 5, this one received 4. So it's okay. So that's my index, H index. So that's H index. And if you want to, for example, get a very practical example, let me. Okay, I think you will see the screen. Let me share with you. This is a Google Scholar. This is coming from Google Scholar service. So let's look at this H index. This is 14, for example. If we consider all the years, it's 14. Why is it 14? Let's see why it's 14. So this is the number of applications: 1, 2, 3, 4, 5, 6, 7, 8. Why I don't have H index of 80? Because not all of them, not all of the 8. Cannot have this 8. Of course, this is still 8. I want to have more H index, not 8, maybe 9, 10, 11, 12, 13, 14. You see, my H index was 14. Why it stopped here? Why it stopped here? Why not go to this number 15? Why not 15? Because at this level here, number 15th publication, the number of citation is 10. So, and it starts reducing. So only at this level, which is 14, this is number 14, the number of citations are 17, means it's 14 or more. So I stop at 14, means I have 14 articles, each of which have 14 or more citations. If I move to 15, no, because yes, I have more than 15, I have 20, but this 15th have not 15 or more citations. So I will stop here. I hope this is a little bit complicated at first, but I hope you got the point. So okay, we had half an hour more. Sorry for that, but that's all the things I wanted to say. Finally, this is just this altmetrics, just for your information. This is not important for you now, but just for your information, for comprehensiveness and for completeness. There is something now called alternative metrics. Alternative metrics means so this is alternative metrics, means you don't go for the citations. You break from the citations as an indication of the impact and quality. So the alternative of complementary measures is to traditional bibliometric measures um, is not using the number of citations, impact factor. They are using actually things related to Wikipedia mentions, discussions on blogs, so coming from websites, other venues, social media, mainstream media coverage like magazines, newspapers, cross references to reference management system like Mendeley, how many times your papers were mentioned there, social media like Twitter, Facebook. So this kind of mentions, they collect all these. And one of the companies, one of the tools they are using this altmetrics is called PlumX. Maybe sometimes you see these uh, symbols. So this is coming from PlumX. PlumX is a tool, uses images like this to show the traditional metrics like citations, as well as the more recent metrics like downloads, number of downloads of your articles from different databases, feed views, online comments, number of likes. Okay, this is from social media, shares, tweets, etc. So this is just an alternative, but of course, as expected, the alternative metrics have their pitfalls, drawbacks, and there is a heated debate, a lot of discussion around them, whether this is a good way for replacing or complementing these traditional scores. And that's it. So again, I apologize for taking almost half an hour more than expected, but I wish that you have gained some knowledge and you have learned a little bit about, again, our agenda was um, not only publication, not only publishing, but a little bit about the, this is our agenda. I hope that when you cross-check this agenda, a little bit about the publishing, um, what's the concept of publishing, what to publish, where to publish, and of course the common publishing terms, things about the publication itself, publishers, and also the type of metrics. So again, I know it's very late, but I will be happy to stick around for a while, receiving any comments, any corrections, additions, or questions you have. Okay, guys. So if there anything, any question, please feel free to unmute yourself or write in the chat.
So far, no questions, sir.
Okay. So who is that? Okay, Rahman.
Yes, yes.
You have a question or no question?
Sorry, sir. Hello.
Sorry, you said you have a question or?
No, no, sir. So far,
Okay,
no
okay.
question.
Okay, no problem. Okay.
Good,
Good,
I have
fine.
a question.
Yeah, please go ahead.
Do you have any like tips in writing an abstract, a good abstract?
Actually, this is a very good question, which is very difficult to address in this time.
Okay.
For writing, actually, what I can give you is a separate talk, really. Actually, we did have a separate talk previously in the beginning of this year about writing, about this part. Here, this part about the manuscript, sorry, about the, where is it? About the manuscript here.
Okay.
So we have a separate talk about this, and we can repeat this if you want. Actually, this is a very good topic, really, which is all about producing the manuscript. It's not about the scores, what is happening later on, what's happening after this line. It's about what's happening after doing research, and before submission. So in this process of writing. So there are a lot of tips, of course, from the language, from the presentation, because you have to look for the content. You have to know what's the expected content in the journals, in the manuscript, from different parts of the journal. Introduction, and your review of the literature, your methodology, your discussion, the analysis, references, abstract, etc. The title, the style, the presentation, the language, the grammar, and some structures, the process of writing, the mood of writing. Actually, there are so many elements to address here, so many things. Some tools, so it also helps you in writing, some rituals that people use for writing. So there are so many things. So it's very difficult to address in a single answer. But really, I wish that we can have some feedback. So if you are still interested, maybe we can produce another talk about this, or can repeat also the same talk we had before. Sorry,
Okay.
Razin, is that okay?
Yes, okay. I also have another question.
Yep.
I mean, in general, which one would you recommend first? Like, is it going according to, let's say, in a way like a introduction, literature review, methodology, result and discussion, or you can have like the other way around? So which one should you prioritize first? Like, is it intro, then we go to literature review, or is it we do methodology first, then we
Okay.
proceed with the intro? I mean,
Okay. Actually, people have talked already about that. So I will give you the summary of what people already said about that. By people, I mean the other experts, not me. So the other experts already they have said the word about this. So there are few variations, but generally the overall, let's say, um, the overall consensus is about that probably the easiest part to start writing your journal article or manuscript is the methods. This is the easiest part because it will give you some motivation and some momentum, and you already should have whatever you have, whatever you need to write down, because you have done it. So you have already done the methods, means you have done the methods. This is actually the trend of using writing, of doing writing after doing the research. In my talk, if you remember, I am not sure who attended that talk, I introduced also another school thought, which is writing in parallel with doing research. So when you write in parallel with doing research, also the same will apply here, because probably you will start doing your experiments or doing your design. So you document that first. So probably you will find it's easier to produce the methods first because you already did that process and you know what you did, and it's still fresh in your mind. People say that, of course, later on, you will write the abstract the last, although many times we tend to write the abstract first. It is okay. For me, many times I started by writing the abstract. Why? It's just as an outline. It's just as a map for myself to write the other. Then I refine it and replace it. It's not a problem. So although officially you will produce the final version of the abstract at the end, you can still start at the beginning just to give you some kind of roadmap. So you know the different parts, then you expand this abstract into outlines, empty sections in your paper, then you fill. So you can fill the methods if it is easy because you know. Then you can explain the results because you already got the result and it's fresh in your mind what does those results means. So you copy the figures, you copy the tables, you explain the numbers, you have some discussion. It's easier. Then probably, although again the introduction is done after that, although many times often it is possible to introduce the introduction at the beginning. Sometimes I do that, but this is a general consensus that after you finish writing most of the sections, especially the methods and the results and the discussion, then you write the introduction, because in that way you already know what you will face later on. Many times, if you are a good writer, your introduction will have references, citations to later parts of your paper. So you'll say, this is the motivation, this is the context, this is the motivation, this is our problem, this is our solution, and you will refer to where you will find different parts of your solution. So you already have that in methods and results. So you refer to those, you know what will, because the introduction also giving a hint of what you will face in this paper. So you already know that, it's in your mind because you have done it. So then you can introduce those parts. And also you will have maybe extra insight from the results, extra ideas from the methods, extra ideas from discussion. You can also include that in the introduction. And then you write the abstract, and also the conclusion can be written anytime. Actually, conclusion can be written anytime after the discussion and analysis, before the introduction or after the introduction. This is not a fixed, this is not concrete. So whenever you find people talk about this, consider these guidelines. It's a guideline. So probably people are used to do that. Maybe it's safe to, imitate or mimic other people's way. But later on, whether you want or not, you will come up with your own way, because later on, if you are doing this many, many times, you will come with your own flavor. But at the start, roughly again, to summarize, probably if you want to follow most of the people, you start by the methods, then the results, then the discussion, then the introduction, then the conclusion and abstract. Okay, Razin, is that?
Okay, Doctor, it's clear. Thank you very much.
but don't be very rigid. It's okay.
Okay.
Okay, guys, no more question. Again, at the end, really, I apologize for taking more time. Really, we discover time after time that when we have, a very heavy topic, we need to devote more time. Actually, 1 hour is very short, but probably we will announce this next time. So thank you very much for attending. If there is no question, um,
Excuse me,
I
Doctor.
will be sharing the slides with Razin, and
Hi,
Razin
Doctor.
will, yes.
Excuse me, Doctor. Because I've joined late to your session. Can you please provide us with the recording link?
I okay. I think if we are recorded,
Yeah,
this,
we
yeah,
are
if
recording.
the recording will be available on the YouTube of the Energy Sphere.
Okay.
Hopefully, yeah, hopefully we can upload that. This is the intention, really. Sometimes we skip that, but hopefully we can also upload this recording to the YouTube channel for the Energy Sphere, TES, the Energy Sphere and the UNITEN, University National, the Energy Sphere. If you search about that, and there is a YouTube channel. There are also some previous talks already uploaded there. Hopefully, we can also upload this one. And the slides
Thank
also will
you.
be shared with you. I will send to Razin, for example, and he will send emails. He will share this with you. Okay.
Okay. Thank you.
Okay, guys.
Thank you,
Thank you very
Doctor.
much. If that's all, really, I'm glad. I thank you very much for your attention and for patience with me until this. I wish I can see you again in the next talk. We'll have talk every sometimes 2 weeks, sometimes every month, sometimes it depends. It's not very regular, but hopefully in the next time we can see you all. Thank you very much. That's all. And Assalamu alaikum and good afternoon for everyone. Good evening by now. Probably we are already at the evening. Okay, guys. See you.